Good morning students, welcome to Sheba online class. Let's see our class 6, the same topic electrostatics. Inside the topic we learn about the electric field due to an uniformly charged spherical shell. Okay, in last class we learned about the Gauss law will be applicable in the electric field. Okay, so now the statement will be the Gauss law will be applicable in the spherical shell. Okay, in same the electric field at a point outside and the inside the sphere is found using the Gauss law. So in one spherical shell is there, so the charge will be applicable in that shell. So inside the shell the charge will be flow through the all surface area. So outside of the shell also the same charge will be applicable in surface of the area. So this is we see this diagram. So one circle spherical shell is there. So inside the charge will be applicable. So the same charge inside the charge will be flow through in outside. Okay. So they separated, they uniformly distributed the charges. So in circumference of the circle the charge will be distributed in outside, the circumference will be flow through in same circumference. Okay. So it's distributed each other in same area. So thus the area will be covered in the surface of this spherical shell. So it's the center point we taken as a radius. In center midpoint will be the distance between the spherical shell and the center point is we taken as radius r, and the same shell this center point and the in some distance we cover the point P. Okay. So in this point we measured as a point P. So in between the distance between these area is a small r, is a radius. Okay. It's a spherical shell in between the center of the radius. In this the point P and the in between the distance r is a radius small r. Okay. So in between distance is covered. So in outside of the charges it's measured as a q. Q is a charge. So in inside of the charge is q and the outside of the charge will be measured as it's a uniformly distributions. Okay. So now we see this outside the shell. So it's already we know this formula. Okay. The closed surface of electric field is equal to dA. dA means a surface of a area covered. Okay. So the dA, A is a vector is equal to Q by epsilon naught. Epsilon naught means relative permeability. So Q is a charge. So it's this derivations. It's a vector derivation. Okay. So we transfer into the magnitude derivation. So it's we applicable in a cos theta. Okay. So in vector form it's transfer into the magnitude form. So magnitude form we included the cos theta. Okay. So closed surface EDA cos theta is equal to Q divided by epsilon naught. It's a full of magnitude form. Now we derive this derivations. The closed surface E vector, E is the electric field and dA is the total area cover the circumference of this circle. So dA is equal to Q is a charge and divided by relative permeability. So E will be transferred in this side. So E in closed surface because the electric field be applied inside the closed surface of the spherical shell. In the spherical shell உள்ள வந்து நம்ம என்ன applicable பண்றோம் அப்படினா electric field வந்து கொடுக்கிறோம். ஓகே. சோ அது கொடுக்கும்போது நமக்கு என்ன ஆகும்? சோ in example ஒரு பால் எடுத்துக்கலாம் நம்ம. சோ அந்த பாலை வந்து நம்ம வந்து ஒரு பிரஷர் கொடுத்து ஒரு இடத்துல வந்து நம்ம போடும்போது அது ரிட்டர்ன் சப்ளை எப்படி இருக்கும்? நம்ம எவ்வளோ ஃபோர்ஸ் நம்ம அப்ளிகபிள் பண்ணுறோமோ அதே தான் நம்மளுக்கு ரிட்டர்ன் சர்ஃபேஸும் கொடுக்கும். ஓகேவா? ஸோ ரிட்டர்ன் ஸ்பீடும் அதே மாதிரி தான் இருக்கும். ஸோ அதே தான் அந்த எலக்ட்ரிக் ஃபீல்டு நம்ம உள்ளே அப்ளிகபிள் பண்ணும்போது இந்த ஷெல்லை வந்து நம்ம என்ன பண்ணிடுறோம் அப்படின்னா க்ளோஸ் பண்ணிடுறோம். ஓகே. ஸோ அப்போ க்ளோஸ் பண்ணும்போது அந்த உள்ளே இருக்க எலக்ட்ரிக் ஃபீல்டு என்ன ஆகுது? வெளியே ஈக்குவலாக டிஸ்ட்ரிபியூட் ஆகுது. ஸோ டிஸ்ட்ரிபியூட் ஆகும்போது இது வந்து சார்ஜ் வந்து என்னவாக இருக்கலாம்னா எக்ஸாம்பிள் வந்து பாசிட்டிவ் சார்ஜாகவும் இருக்கலாம் இல்லை நெகட்டிவ் சார்ஜாகவும் இருக்கும். மோஸ்ட்லி நம்மளுக்கு வந்து பாசிட்டிவ் சார்ஜஸ் தான் நம்ம எடுத்துக்கிறோம். ஓகேவா? ஸோ அதனால் இது பாசிட்டிவ் சார்ஜாகவே அசியூம் பண்ணிக்கோங்க. ஸோ லிசன் இந்த ஈக்குவலி டிஸ்ட்ரிபியூட்டட் த சார்ஜஸ். ஸோ அப்படி ஈக்குவலாக டிஸ்ட்ரிபியூட் ஆகும்போது எல்லா இடத்துலையும் சேம் சர்ஃபேஸில் தான் டிஸ்ட்ரிபியூட் ஆகுது. ஸோ அதை தான் நம்ம என்ன பண்ணுறோம் அப்படின்னா எல்லா இடத்தையும் நம்மளால் மெஷர் பண்ண முடியாது. ஸோ வி மெஷர் திஸ் certain point. Okay. ஸோ இந்த பீன் பாயிண்ட் வச்சுருக்கோம்ல இந்த சர்டன் ஏரியாவை மட்டும்தான் நம்ம மெஷர் பண்ணுறோம். ஓகே. ஸோ இந்த மெஷர்மெண்ட்டோட ஆங்கிள் இந்த மெஷர்மெண்ட்லேருந்து எலக்ட்ரிக் ஃபீல்டு என்ன ஆகுது? வெளியே டிஸ்ட்ரிபியூட் ஆகுது. ஸோ டிஸ்ட்ரிபியூட் ஆகிற இந்த லைனையும் ப்ளஸ் நம்ம எடுத்துக்கிற ஏரியா வந்து என்ன சொல்லியிருக்கோம் அப்படின்னாக்கா, it's a perpendicular to the area. Okay, it's distributed in perpendicular area. It's a unit vector. So this will be measured. Okay, so E is closed surface dA is equal to Q by epsilon naught. So E 4 pi r square, it's a surface area formula. Okay, 4 pi r square is equal to Q by epsilon naught. So E is equal to Q by epsilon naught. It's transferred into the divided symbol. So it's a multiplication equal to in the side varumbodhu divided symbol. So 1 by 4 pi r square, it's a magnitude form. Okay, it's not a vector form, it's a magnitude form. So this will be transferred into the vector form. So E vector is equal to Q by epsilon naught 1 by 4 pi r square is a vector. It's a unit vector, no? So the r is a r cap. It's a vector form. So now this area will be covered. Okay, so this is a transfer of area vector. It's perpendicular to each other. So the line will be in equal. Okay, the electric field also equal, its charge distribution and the area also perpendicular to equal. So this equal is a 90 degree and the equal to 0 and the 0 degree is equal to 1. Okay, so the cos theta 0 degree is equal to 1 will be applicable. So now the Q is a charge is greater than the charge inside the surface we applied, means it's a Q is lesser than O. So the charge will be distributed outside, means it's a Q is greater than O. So now we start about conductor at electrostatic equilibrium in conductor. So conductor means what? It's allow the current charge will be easily flow out through the areas. Okay, so which allow the current pass throughly easily. Okay, current என்ன ஆகும், பாஸ் ஆகுது ரொம்ப ஈஸியாக குயிக்காக வந்து சார்ஜஸ் வந்து பாஸ் ஆகி டிஸ்ட்ரிபியூட் ஆகும். So in this we see this diagram. So it's one conductor is there. Okay, in conductor is a sample of an example a watch, hand watch will be noted. Okay, so this is a metal, one type of metal or one conductors. Okay, so the charge will be passed out through this side of this surface. Okay, so it's a positive charge. We inserted the charge is a positive charge. That charge will be distributed in that metal and flow through the areas. Okay, so this area, the positive and the negative charges in this metal, we already inside the charge is a negative charge is there. Okay, so in this positive charge and the negative charge will be combine each other. So it's a charge will be distributed in equally in positive and the negative charges. So this charge in flow throughout in this side, it's distributed. Okay, in outer surface it will be distributed, means it's a negative charge will be transferred to distributed. Okay, so நம்ம வந்து என்ன பண்ணுறோம், சார்ஜ் வந்து உள்ளே பாசிட்டிவ் சார்ஜ் இன்க்ளூட் பண்ணுறோம். ஸோ அந்த சார்ஜ் என்ன ஆகுது, வெளியே டிஸ்ட்ரிபியூட் ஆகும்போது அப்படின்னா நெகட்டிவ் சார்ஜாக டிஸ்ட்ரிபியூட் ஆகுது. ஸோ உள்ளே இந்த மெட்டல் இந்த கண்டக்டரில் வந்து என்ன அப்படின்னா ஆல்ரெடி வந்து நெகட்டிவ் சார்ஜஸ் இருக்குது, நம்ம பாசிட்டிவ் சார்ஜஸ் கொடுக்குறோம். ஸோ ஆல்ரெடி we know that. Okay, so opposite charges will be attract each other, same charges will be repulse each other. So this way will be applicable in this diagram. So we included the positive charge. So in this combination of charges, the negative charge will be separated in this form. Okay, it will be attracted in this positive charge. Okay, நம்ம உள்ளே இன்க்ளூட் பண்ணுற பாசிட்டிவ் சார்ஜ் கூட இந்த நெகட்டிவ் சார்ஜ் என்ன ஆகுது, உள்ளே இருக்க நெகட்டிவ் சார்ஜஸ் மட்டும் என்ன ஆகுது, ஸ்ப்ளிட் ஆகி அட்ராக்ட் ஆகிடுது. ஓகே, ஸோ இன் திஸ் ஏரியா, ஓகே, வி நோட்டிஸ் திஸ், இந்த ஏரியா மட்டும் என்ன ஆகுது, நெகட்டிவ் சார்ஜஸ் வந்து அட்ராக்ட் ஆகி செப்பரேட் ஆகிடுது. ஸோ அகெயின் பேலன்ஸ் இருக்க பாசிட்டிவ் சார்ஜஸ்லாம் என்ன ஆகும் அப்படின்னா வெளியே ரிப்பல்ஸ் ஆகும்போது என்ன ஆகுது, நெகட்டிவ் சார்ஜஸ் மட்டும்தான் டிஸ்ட்ரிபியூட் ஆகுது. ஸோ அதனால் இந்த பாசிட்டிவ் சார்ஜஸ் இந்த சைடு வந்து நெகட்டிவ் சார்ஜஸோட ஸ்டாப் ஆகி நின்றுட்டு வெறும் நெகட்டிவ் சார்ஜஸை மட்டும் வெளியே டிஸ்ட்ரிபியூட் பண்ணுது. ஓகே, ஸோ இன் திஸ் டயக்ராம் வி நோட்டட் in this direction will be the electric field be distributed out surface. So the external field of this side, நம்ம பாசிட்டிவ் சார்ஜஸ் அப்படின்னு பார்த்தோன்னா பாசிட்டிவ் சார்ஜ் எந்த சைடு டைரெக்ஷனில் ஃப்ளோ ஆகுது, இந்த இடத்தாண்ட பாசிட்டிவ் சார்ஜ் வந்து இந்த நெகட்டிவ்க்காக ஃப்ளோ ஆகுது. ஸோ இந்த சைடு வந்து நெகட்டிவ் சார்ஜஸ் flowing through the positive charge in this area, okay, in this direction, opposite direction, okay. So the two direction will be opposite, so the electric field of the direction is opposite, okay. So the E is equal to 0, so E is inside the 0. So if in this conductor, inside of the surface, it will be noted on the surface area will be empty. Because of the charge, all the charges in outer surface, it will be distributed equally. So the inside of the surface is a empty surface. There is a no charge, okay. Inside of the surface, there is a no charge. It's a empty surface. So the charge is 0. Net charge is also a 0, and the electric field is also a 0. So it will be transferred into this side. This charge will be transferred into that side, okay. So the empty surface, it in center of the area midpoint is there is a no charge, so it's a 0 charges. So inside net charge also 0. E, the E vector, that means electric field vector, it's a perpendicular to the surface of E is a sigma divided by epsilon naught, okay. So it's a E vector formula, sigma divided by epsilon naught. It's a potential inside the surface also same. It's a potential inside the surface is also a same vector, okay. So the electric field will be applied inside, means the empty, it's inside the charge will be empty, the throughout area will be empty. So its a charge is also 0. So the inside of the surface is also a same potential area will be covered inside and outside of the surface. So now we notice the surface area will be covered. So already we know the spherical shell diagram. So the R, okay, small r, the small r is equal to R. It will be combined the total surface area. So the R is equal to full radius, the E vector is equal to Q by epsilon naught 1 by 4 pi R square. So the inside of the shell surface, so it's a closed surface area, E vector dot dA is a distance covered area. So dA vector is equal to Q by epsilon naught. So it's a closed surface, E dA, cos theta is equal to, so the 0 degree is equal to 1. So its a cos theta value is 1. So it's not be applicable. So the Q divided by epsilon naught. It's a closed surface of E dA is equal to Q by epsilon naught. So E is equal to the 4 pi R square. So is equal to Q by epsilon naught will be apply same. So here also the electric field E is equal to 0. So the totally the electric field be applied the inside the objects, it will be distributed, means inside the object the electric field will be 0 charges, okay. So this is a spherical shell and the electrostatic equilibrium will be applicable. Electrostatic shielding. So we see this diagram, it's a one of the metal conductor, okay. So in this metallic conductor, in center points we will be noted, okay. The center point is a no charges is there, okay, because of the charge will be distributed throughout the outer surface area. In example, we have taken one cage, okay. So in rainy season, we all know that the thunderstorm will be formed, okay. So that thunderstorm is a best example for this diagram. So in that thunderstorm, it's flow through our human body, okay. In the electric field, in that field will be attract in a human body, human beings. So see this diagram, one human is there. So the thunderstorm will be applied in this metal cage, okay. This is one type of the metal cage. So this metal cage, the electric field will be applied in throughout the areas. So in this area covered in the metal cage, so it's a positive or negative, any other electric field charges is there, okay. So என்ன ஆகாது அப்படின்னா, நம்ம வந்து ஒரு மெட்டல் கேஜ்க்கு உள்ளே இருக்கோம் அப்படின்னா அந்த தண்டர்ஸ்டார்ம் என்ன பண்ணாது, உடனே அஃபெக்ட் பண்ணாது அப்படின்றாங்க, ஓகே. So there is a charges is a 0 charge in this metal cage, means the charge will be distributed in 0 charge. There is a no value for the charge. It's no, not at all in this diagram. So in this person will be inside the cage, okay. So the thunderstorm is applied in throughout the outer surface area of the cage. So it will be flow through in outer metal state. So it's a flow in a ground state. Okay, already flow through in this metal state of the outer coverage area. So it's already flow through in the ground state of this charge. So in this person will be safe inside the metal cage. Okay, so this is the electrostatic shielding of the best example. So in the field will be applicable in outer surface only, not the inside of the surface coverage area. Okay, so in the inside is the charge is also a 0 and the electric field will be applicable in also a 0 charges. So the Faraday cage, so we notice this diagram. So it's a negative charges. So it's a negative charges and this one is a positive charges. So we apply the negative charge in this metal, it's a conductor, one type of the conductor. So it will be transferred into the positive charges. So this positive charge is we already included the internal surface also, yeah, electric field will be there. So outside also same the direction is electric field will be exit on this diagram. So the electric field is exit is equal to the electric field will be included this conductors. So its direction will be in the opposite because of we noted on this one particular area. So the electric field exit is equal to the electric field will be included. Okay, it's the direction is electric field will be in this surface. This direction will be flow through in this ground state. So its area is perpendicular to this. So its direction is the opposite direction. So its a cage also a 0 degree. So 0 degree is equal to 1. So the cos theta cos 0 degree is equal to 1, right? So it's directly proportional to this diagram. Now we see the electrostatic induction. So the induction means in this electric field be inducted the circumference of one spherical surface. Okay, it's a induction. So in the opposite charges is there. We have taken see this diagram, it's a one of the metal mirror. Okay, so in a phase coverage mirror, so we taken one rod. This rod is a fully applicable in a negative charge. Okay, so in nearby this it will be attracted. Okay, because of we taken one negative rod is there. So it combined to the one metallic mirror. Okay, so the metallic mirror fully charged in the positive charges. Okay, so that metal rod is a negative charges. So we attracted these two metals. In example, இது ஆல்ரெடி எப்படி இருக்கும் அப்படின்னு பார்த்தா ஒரு கண்டக்டர்ஸாக இருக்கும். ஓகே, ஸோ இதில் வந்து ஃபுல்லாக வந்து பாசிட்டிவ் சார்ஜஸ் அப்ளிகபிளாக இருக்கும். அந்த மெட்டாலிக் ராடில் நெகட்டிவ் சார்ஜஸ் இருக்கும். நம்ம இந்த ராடை வந்து எதுக்கு கொண்டு வரோம் அப்படின்னா அந்த சர்ஃபேஸ்க்கு கிட்ட எடுத்துகிட்டு வரும்போது அது அட்ராக்ட் ஆகுது. ஓகேவா, ஸோ அது அட்ராக்ட் ஆகுது. எதனால் அட்ராக்ட் ஆகுது அப்படின்னா ஆப்போசிட் சார்ஜஸ் வந்து அப்ளிகபிள் ஆகுது. அது இதுலேயும் வந்து நெகட்டிவ் சார்ஜஸ் வந்து இருக்கும். ஸோ அது என்ன பண்ணும் அப்படின்னா அட்ராக்ட் ஆகும்போது பாசிட்டிவ் சார்ஜஸை செப்பரேட் பண்ணிக்கும். It split out this areas only. Okay, it attracted this areas. So this area only negative charges will be is there. Okay, so in it's a wire, it plugged surface. Okay, the wire என்ன பண்ணிருக்கோம் இங்க plug பண்ணிருக்கோம். So இந்த negative charge என்ன ஆகும் அப்படினா நம்ம வந்து switch on பண்ணும்போது இது வந்து ground state க்கு போகும் இந்த negative charge. So it will be transferred into the ground state. So the only positive charge will be inside this surface of the metallic mirror. Okay va, so it's a one of the conductor. இதுக்கு கீழ இருக்க ஸ்டாண்ட்ல வந்து என்ன ஆகாது அப்படினா சார்ஜஸ் ப்ரொடியூஸ் ஆகாது. எதனால அப்படினா இது வந்து இன்சுலேட்டிங் ஸ்டாண்ட். ஓகே, so it's a conductor, it's a metallic conductor. In a lower surface it's a insulating stand. So there is a in between distance is a not charges will be produced. Okay, so this is the surface of this metallic mirror. So the charges will be neutral. So inside the conductors the charges will be a empty surface, it will be a neutral surface. Okay, so after that the sphere is a rest at insulating stand. After that the charges rod is brought near the conductors. So we already know that. Okay, so one metallic conductor is there, no? So inside the charges will be produced positive or negative charges. It will be split out throughout the surface area. inside the charges it will be the 0 charges. So same will be applicable. In XII points will be there. Okay. So this only included in the ground state charges. Okay. So we split out the other charges. The negative charges produced means it's throughout the ground state. So this charge will be noted on. After that this charge will be not connected in this surface. Okay. So the negative charge only produced in this area only. It not connected in the ground state. Okay. So only the positive charges will be attracted this conductors. So now the conductor sphere is connected to the ground state means its a charge will be produced in the positive charges. So its a charges removed in this electrons. There is a inside the surface there is a 0 electrons only produced. Okay. So it will be flow out through the ground surface of the state. Its negative charge in the rod, its a wire is removed. So this removed means the positive charge remains, the near charge will be that rod. The charge rod is taken away from the conductors. This charge rod is removed. After that the positive charge gets distributed uniformly. Okay. So on the surface of the conductor in this figure, it's a neutral conducting. So finally we introduce its conducting will be the neutral conducting. So becomes a positive charge will be neutrally conducted in the various steps of the electrostatic induction. Okay. So now we taken the classes, 4 classes is there. One is the spherical shell, another one is the shielding, and another one is the equilibrium. Spherical shell we note it on the charges included, that they will be equally distributed, inside the charge will be 0. So in the equilibrium of the surface, so its electric field also 0, the net charge will be also the 0. So after that we introduce this surface of the induction and the shell. Shielding. So shielding means it's a thundering form. Okay. So the thunder will be distributed in one surface metallic cage. So it's equally distributed in outer surface only, not in the inside of the metallic surface. So it will be all flow through in the ground state only. Okay. So our human being in nearby one metallic surface means we are safe to the thunderstorm. Okay. So it's not affected any surface of any areas. Okay. So after that we note it on the induction. Induction is the neutrally charges. So this one also a neutrally charges flow through this areas. Okay. It's a opposite charges will be conducting in neutrally. So thank you students. We send a homework in a WhatsApp. So we write it on the class book and note it. So thank you students.